Let's put together what we've learned so far. In this video, I'll walk you through an example to see in detail how the shell processes the command line. There was so much information, and I'm sure that this example will help you a lot to deeply understand how the shell works. Let's take a look at this command. The ls command lists the contents of the user's home directory, which is stored in $home variable, and the entire output will be redirected to a file. There's a command substitution, and if I run the command, we'll see that it returns the current hour and minute with an underscore in between. So the file name will be the current hour underscore current minute and the .txt. Now let's see what the steps are and the actions the shell performs before it executes the command. In this example, the shell reads its input from the user's terminal, and the first step is tokenization, in which it breaks the command line into words and operators. Let me remind you that a token is a sequence of characters considered to be a single unit by the shell. To decide when a token starts and ends, the shell is looking for special unquoted meta characters. In this example, there are two unquoted meta characters, space and the greater than sign. Note that the space in the command substitution does not count as a meta character because it is quoted, and we are looking only for unquoted meta characters. The tokens are of two types: words that don't contain any meta characters and operators which contain at least one unquoted meta character. So we can see that there are three words: ls, $home, and the command substitution .txt, and one operator, the greater than sign. Note that dollar is not a meta character, so $home and the command substitution count as words. This was the first step, which is called tokenization. After tokenization, the shell will move on to the second step, which is command identification. There are two types of commands: simple and compound. A simple command is just a sequence of words separated by blanks and terminated by either a new line or one of the shell's control operators, and a compound command is a command that starts and ends with a bash reserved word such as if, while, for, and so on. This is a simple command because it doesn't start with a reserved word. A simple command will be terminated by a control operator or \n. Since there are no control operators here, the whole command line will be interpreted as a single simple command, and the invisible new line or \n at the end of the line terminates the command. Note that greater than is not a control operator but a redirection operator, and that's why the greater than sign and the command substitution are still part of the command. After command identification, the shell will move on to the third step and perform all the required expansions. Take a look at this slide. There are 8 types of expansions performed in the following order: brace expansion, tiled expansion, parameter and variable expansion, command substitution, arithmetic expansion, process substitution, word splitting, and the file name expansion, aka globbing. In our example, there are 2 types of expansion: $home, which is a parameter expansion, and the command substitution. This is the value of $home, and this is the output of the date command. So the shell will replace $home with X value and the command substitution with the output of the command. So the command will look like this: ls/home/student greater than 11_16 .txt. Let's move on to the next expansions. Is there any arithmetic expansion or process substitution? No, there isn't, so it will move on towards splitting. The results of an expansion that didn't occur within double quotes are subject to our splitting, and because the expansions were not in double quotes, their result is subject to our splitting. To perform word splitting, Bash needs a delimiter, and it uses the IFS variable, which by default contains space, tab, and new line. The results of both expansions do not contain space, tab, or new line, so there will be no word splitting. There's no file name expansion, aka globbing, because there are no unquoted asterisks, question marks, or square brackets. That was the third step of the whole process, known as expansion. The fourth step is quote removal. After the preceding expansions, all unquoted occurrences of the characters backslash, single quotes, and double quotes that didn't result from one of the expansions are removed. In our example, there are no backslashes, single quotes, or double quotes, so it will move to the next step, step 5. This step is called redirection and is the last one of the command line processing flow. In this step, the shell will look for any redirection operators. There's one redirection operator, the single greater than sign, which performs output redirection. The shell will know that it has to redirect the output to a file instead of the standard output, which is the terminal. In this case, the file name is the current hour, underline, current minute, .txt. And the shell will create the file if it doesn't exist or overwrite it if it already exists. This is what a single greater than sign does. And that's all. The shell has processed the command line and can execute the command. In this video, we've put together the summaries of all the videos in this section and the previous one. Now you should have a good understanding of how the shell processes the command line before a command gets executed. This entire section is really important. I know it's not an easy one, but if you fully understand it, it will put you at the top of the Bash programmers. Watch the videos again, write the code and try to understand each detail. Also, take the quizzes and do the hands-on challenges that follow, and I'm confident that you'll have a clear picture of how Bash processes the command line.